No. No, but it's good that you thought of that because sort of similar processes are taking place in that organelle and in another one. Chloroplast. What's chlorine gas made of? Duh. It's one of the few gases that has a color. Green. What's chloro mean? It means green. Chloroplast. A plast is a membrane-bound organelle. It's a piece of a cell that has its own little membrane. Okay, a plast is a membrane-bound organelle, and this organelle contains either something that's green or something that makes it green, something related to green. Okay, it's called a chloroplast. And where are chloroplasts found in plants? Inside cells. And where are the cells found that have the chloroplast? Prominently in what structure? Leaves. Leaves. Okay? Found in the leaf. All right. Okay? A leaf. You don't have to worry about the names of these layers, but what they've taken here is this leaf and then sectioned the edge of it. Okay? And so you're looking at a section of a leaf, and you see an outer upper layer, an outer lower layer, stoma. What does stoma mean? Anyone know? Shut your stoma. Mouth. Yeah, mouth. Yeah. So, well, these look like little mouths. They're little openings. Those are little openings that allow gases to move in and out of the leaf. Gases like CO2, O2. Name another gas that you can find inside a leaf. You know what it is. You're going to feel really stupid. Water. Does not matter exist in different phases? Is water always liquid? No. Yeah. Water in gaseous form can pass through these little mouths too. That's why plants wilt when it gets hot. Okay, they're losing too much water through those pores. So those pores have to close up when it gets hot. Okay, and there's a particular cell that they're showing here. It's called a mesophyll. Phyll means leaf, meso, middle. Geez, it's a cell in the middle of the leaf. Okay? And inside this mesophyll cell is a structure called a chloroplast. Chloroplast has three sets of membranes. There's an outer membrane, an inner membrane, and then inside that is this system of membranous tubes that are connected together. The energy source for making the carbohydrates, once again? Photons. Photons. Okay, and what are photons? Well, I know he's been stressing photons to you in other terms. He's not going to get away with just saying it's light. Yeah, it's a form of what? What kind of radiation is that called? There's a whole spectrum. It's ultraviolet. Oh, gee, it's a EMR spectrum. It's electromagnetic radiation, right? Light is just one narrow little window in that whole spectrum.
Visible light.
Okay, all the way from gamma rays, you don't want to stand in front of those, to radio waves and beyond, okay? Gee, microwave. Yeah, sitting in your house, right? You're cooking with radiation when you use a microwave oven. Shorter wavelength, fill in the blank.
Longer.
Short wavelength, higher energy.
Higher energy, what else?
Long wavelength.
Well, no. If the wavelengths are short.
Higher frequency.
Huh?
Higher frequency.
Higher frequency. What does frequency mean?
The amount from one point of edge.
From the amount of time it takes for one wave for one wave front to pass and another one to follow it, right? Okay, so that's frequency. Which end of the spectrum do you want to avoid the most?
Gamma.
Yeah, this end, right?
Yeah, right.
Do you have a common word for infrared radiation? What do you call it? If you talk about infrared radiation, what is that? Oh gosh, it's hot today.
Big Denny's.
Heat.
Heat lamps.
Infrared radiation is heat. Okay? What's
Infrared lamps.
worse? Stand close to a fire, not close enough that you set yourself on fire. What's worse? Stand close to a fire or stand out in the sunlight all day? This, ultraviolet. That's high energy radiation, right? Compared to infrared. This stuff damages your DNA. Plays havoc with cell membranes. Causes all kinds of damage. Okay? So the source of energy for photosynthesis is going to be this part of the spectrum, and you observed parts of these spectra of the spectrum in your lab, didn't you? And did you guys get to excite electrons? Huh? Yeah. You excited these electrons, and then what happened? Yeah, they dropped back down to ground state, and when they did that, yeah, they were less excited, but not only that, they emitted something, a photon, and you were there, and you were receiving the photon, right? That photon was actually triggering a chemical reaction in the back of your eye, where your retina is, and the cone cells primarily of your retina, okay? Yeah, one of the points Mr. Sullivan wanted me to make with you is that chemistry is not this thing that just exists on the lab bench in a chemistry lab. Okay? It has real impact. It has real impact on your life. It has a lot to do. It has the most to do with what you are physically. Okay? The stuff you're made of. That's all due to chemistry. All right, back to the old chloroplast.